Good morning, guys. Today we'll be seeing the procedures to be followed while simulating the CNC turn. So this is the actual component that we are going to machine. So these are all the dimensions which are in centimeters. So now I'm starting to model the component. So select the sketch. I'm selecting the front plane. I'm going to model the component using sweep revolve command. So initially I'll be sketching the half of the component, and then I'll be using the revolve command to fully complete it. So going to use line command to create the sketch. So I've traced this particular profile, and now I'll be giving all the dimensions. First one, so I'll be giving the dimensions of the length, and then finally I'll be giving the note the diameters. So initially this particular length, you can see it is 0.5 centimeter, or it is 5 mm, and the distance from this center point to the next point, so you can see it is 1 centimeter or 10. Its distance it is 0.5 centimeter from this particular location to this location, right? And from this point to this it is 2 centimeter. Based on this diagram, we can assume these two lines are collinear. So I'm giving the collinear constraint. So select these two lines, go to constraints, click collinear. So these two lines are made collinear. Next, this distance from this particular point is 2.75 centimeter. Press D button. So this value is 2.75. Let me check once. 2.75. And the whole distance, okay, from this point to this point is 5. This is 4.4. It's 41. 41. 0.75. 27.5 is this particular distance, and from here to here it is 4.125. Now we'll be proceeding with the dimensions. The diameters. So the maximum diameter is 3 centimeter or 30 mm. So the next diameter is somewhere around 17. This is half, which means 30 divided by 2. Half of this. Next is this 17.5 divided by 2. You can see, so everything is now since these two lines are made collinear, so you'll be able to control this feature as well. And then this is 12.5 mm divided by 2. So this is the profile. So let me assemble it properly so that you'll be able to see these dimensions in a better manner. So these are the dimensions. Okay, so all dimensions are in centimeter. Here we are converted that to finish sketch. To create, I'm going to use the revolve command. The profile is selected by default. Select the axis alone, so we'll be able to create this. So now we have a few fillets here, which we have to create. This fillet radius is 0.125 centimeter. Here the fillet radius is 0.25 centimeter. So go to modify fillet. I'm selecting these two arcs using control and 0.25 centimeter or 2.5 mm. Very similarly, fillet. This is 1.25. So we are now able to successfully create this model. So now we wanted to create the references for machining. So for this, once again, I'm selecting a particular plane, create, project. In project, can use intersect and select all the faces. I'm selecting all the faces in this particular view so that it will be easy for me to make the traces. You okay? Able to create this traces which will be useful for us, and finally I'll be creating another line which will be using to do the chamferings, and this is a straight line. We'll be using it to turn the component now initially after a facing operation. Let me give the finish sketch. So after this we are now able to now successfully model the component and create the references as well. I have saved this. So now let us go to the manufacturing workspace. So we'll be already exposed to this particular workspace. Here, if by default it will be in milling, so use turning operation. So one setup is there. Right click, new setup. So now here we have few functions to be done. First one is selection of the machine. So let us select the available machine. So select this. So my machine, if you go and click, you have ordered as generic mill turn lathe. I am selecting this particular machine. It is available there. Generally, if you see, so here you can see, here it is given as safe, and here this is given as check. Generally, whenever you wanted to do any machining operations, it should be on the opposite side of the tool movement. So we are just going and clicking the flip Z axis, and then we'll be trying to fix the stock. Once again, to fix the stock, now we'll go to this particular component. Totally, you can see the dashed lines. No, this is the actual component, and you have, in addition to that, this particular face. We are going to only uh, machine the topmost portion. We are not going to machine the hatched portion. So in that case, the total distance is uh, 5 centimeter, and then you have some small clearance here, which you can assume it to be 1 mm or 2 mm. So based on this, we are going to model it. So stock, go and click this. So it's an relative size cylinder. You can give fixed size also. So the stock diameter, we are assuming it to be 3.125. So this is 3.31.25, and length I am assuming it to be 50. The total length is 50, and let me give it as 52 or 54, so that 4 mm clearance will be there. And then the mode portion, offset from front, I'm going to give an offset from the front. This is what I'm going to do, and in the front offset I'm going to give as 4 mm. Okay, so 4 mm clearance is there. So it's up to you, whether you can give 52 and give offset as 2, depends. And then post processing, you can modify the number 110 plus, just giving the name. Okay. So I have successfully set the setup operation. Now the next task that is to be done is the facing, turning, and grooving operation. So we'll be doing one after the another. So initially, generally, we'll go for facing. Turn facing, you just click the turn facing option available, and you will be prompted to select the tools. So generally, in documents, you have the plus button to select the tool. Go for general turn, and you will be having the different options, folder setup. So if you want, you can modify these insets options. All these things are available here. So accept, and I'm selecting this particular tool. So the geometry is selected. All other options are no, by default we can use it. So we can see successfully this particular operation is completed, the tick marks. So let's try to check how the simulation is happening. So you can see, so the 4 mm is cut in a single pass. If you want, you can modify the number of passes as well to 2, because if you feel, if since clearance that we are given is 2 mm, the offset, we can increase that as 2. Next one, we are going to do the turning operation. Once again, go to turn of profile. Here facing is somewhat very simple, but turning, we have to be more careful in this. So we'll be using the same tool. The only difference that we are going to make is the model. So this is where we will be using the references that we have already created. So this, go and check this model. and it will be asking for model contour. So just go and select this model contour. So I just selected this model contour, and when we select the model contour, what happens is sometimes it might select all the things. So keep it as open chain, open and check whether it is in the closed chain mode or open chain mode. Give OK, and then what is the front and what is the back. This has to be within this no particular range, so that machining will be happening only on this particular region. So let me now give OK. So the processing is happening here. The tool path is created. Let us hope we are able to create. Yeah, so you can see now the tool path is created. So let me once again do the simulation once again. So let me simulate this. Simulation is happening, you can see. So it is gradually removing the material. You can see it is removing the component based on the reference and the front and back that has been given as the guide. Okay, so this operation is also successfully done. So let us give exit simulation. Now once again we'll go for groove finish, because we wanted to cut this small groove inside, and here we have to select a different tool. We have a separate tool for grooving. Go and click. So turn grooving is available. So just give accept. Select this. So as usual, go and select the model which we have to go for the grooving operation. Select this reference. Okay. Give OK. So over here also, we are able to see that it is able to do this operation successfully. Let us go and check how this particular operation is to be done. I'm not pretty sure whether going on the start simulation, you can see grooving is also been done. So it has been done as a single step. Okay. So we have done the grooving now. So next we'll go for turn finish. Now you can use this normally, since it's a very very close operation. You can use groove, or you can use even this normal turn tool as well. But for more precise operation, I'm going for group. So instead of selecting the top references, now you can select the bottom references. Okay. Okay, now I'm able to select individually. You can see. Okay. Have to be more careful between the front and back, so that also has to be properly checked. We will start this simulation as well. This is the final operation. Okay. So very smoothly this final profile finish as well. Now we have to remove this particular material from the stock. So for that, I have to go and do turning part. So we'll be using the same tool. Model back is the reference for us. You can see with this you will be able to completely remove the material from the stock. Let me do the simulation. So directly the material will be now detached from the stock material. So we have done the simulation successfully. So let me do the simulation from the beginning so that it will be easy for us to see. Let me make the holder as transparent. I'll make the ceramic or metallic paint, whichever will be more accuracy. I'll make it as ceramic first for the time being. Model opacity and creating it. So let us see from the beginning what will happen. I'm reducing the speed so that it will be easy for us to really understand what will happen. So initially it goes for the facing operation. You can see at the bottom there are different partitions. Each and every individual operations are now combined and then it is visualized here. Next operation is your turning operation after facing. So you can see. So I'll just increase the speed along to. So now we have done the grooving and then finally finishing it. So save this and that's all for this particular exercise.